Hello everyone, my name is Suraj Kumar. I am a third year student of BSc Honours Data Science and Artificial Intelligence at IIT Guwahati. So in this video, I am presenting my Term 9 project, which is an extension of my previous ticket classification system. So in my last project, I built models to automatically predict the ticket category and the assignment groups. But in this video, I have added the priority prediction as well with a smart conservative escalation feature. That means if the model is not confident enough to predict the priority, our model will automatically raise the priority to prevent the production outages. So let me walk you through everything. So now let me just brief what is the problem which we are gonna solve. So in any IT organization, every ticket needs mainly four decisions that before it can be resolved. So first one will be category, which tells us which type of issue it is, and the second one will be assignment group, like which team should handle it, what to whom we have to assign it so they can fix it. And the number three will be priority. Priority means how urgent is that issue. Okay, and the number four will be the resolution time and how much time that issue is gonna fixed. So basically in this part we have SLA, that is service level agreement, which is made between organization and the customer to resolve any issue. So our main motive in this project is to predict the categories so that we can save the SLA, right? So in my last project we have solved one and two, like first two problems, the category prediction and the assignment group prediction, right? But in this project, I'm gonna predict the priority of the tickets. Okay. So as I told you, priority is a very critical thing because if there is a production outage and uh, genuine P1, that will be a critical priority, and if it is assigned wrongly to the P4 very low priority, then entire production system could halt, right? So the solution which we are looking for here is to not just predict the priority, but predict it safely using confidence-based escalation. Okay, so for this model, I have used nearly 1,50,000 of IT service desk tickets. Okay, and in our data set, we have majorly four priorities, that is uh, P1, that is critical, then P2 is high, then moderate and low, right? So we have like 1 lakh tickets for of low priority and nearly 1200 tickets of critical priority. So this 83 to 1 ratio between low and critical priority makes the priority prediction significantly harder than category prediction, right? So as you can see in this heat map, the security tickets are mostly low priority since routine security alerts dominate, right? So while business system and we have enterprise hardware, these tickets show higher priority patterns, right? So now let me tell you what is the methodology which we have used here. So in this model, we have built this model in three layers. Number one, we have used TF-IDF along with linear support vector classifier with where we have used class weight in a balanced way, right? So this balanced weighting means misclassifying a critical ticket is penalized 82 times more heavily than misclassifying a low ticket during training. So this is forcing the model to pay special attention to rare but important to critical tickets, right? And in the second layer, we have probability calibration using Platt scaling. So in standard linear support vector, that gives us the raw decision scores, not the probabilities, right? So here we have wrapped it in calibrated classifier CV. which fits a logistic regression on the scores to produce genuine probability estimates between 0 and 1. Okay, and in the layer 3 we have conservative escalation at 60% threshold. So like if our model is 60% confident or more than that, then it will trust the prediction which it have predicted, right? But if it is below than 60%, then our model will escalate it to the higher priority automatically. Okay, so what happens here is if the model is not 60% sure, then lower priority will go to moderate, like P4 will go upgrade it to P3 priority, and P3 priority will upgrade to P2 priority, and P2 will be upgraded to P1. So this is saving, right? So this is kind of risk-aware machine learning that we have designed for real production environments. Okay. So now in the results part, let me show you the results. Our category prediction model, which we achieved, was 87.39% accuracy, whereas the assignment group predicted 88.88%, and in the small priority prediction got 82.94% accuracy, right? So for priority, if we look at the class levels, the critical achieved 66% recall. That means our model catches 66% of genuinely critical tickets despite having only 1200 nearly training examples, right? Whereas our P4, that is low priority, achieved 93% precision and 82% of recall. So for conservative escalation at 60%, which where we have set a threshold of 60%, our nearly 86% of the tickets are predicted with high confidence. That means they are predicted, they are more than 60% confident that it will be the uh, priority of the predicted ticket, right? So along with that, we have nearly 14% tickets which are automatically escalated to safer priority level to save the service level agreement, right? So this means over 4,000 tickets that the model was uncertain about get an automatic safety upgrade. Okay. So now we have an interesting part. I'll show you the live demo. Okay. So now I'm gonna type real ticket descriptions and our system will give all three predictions, category, assignment group, and the priority instantly. Okay. So uh, let me first type complete system outage, all users affected, urgent fix needed. So from the description itself, we can get to know that whole production is halted and all users are affected with that, and the urgency is very high. Okay, so here our model have predicted the priority as high, but at low confidence than 60%, right? So our model has upgraded the final priority to P1. Our model escalated the priority to upper level, right? So this is where this model gets interesting, right? Now, so this was the exact what conservative prediction does. The model was uncertain about the high, so it automatically raised to the critical, preventing a potential production halt, right? And let me give another test. Let me type printer paper jam not urgent. So here in the description, it says it is not urgent, right? Now our priority is predicted to moderate, but at nearly 88% confidence. So here there will be no escalation. Model is very confident enough to predict the priority, right? So as I have shown, the system makes smart, safe prediction across all the tickets. So the conclusion which we have achieved here is, let me just give you a brief of the whole model. We extended our initial ticket classification system with priority prediction, where we have achieved 82.9% of accuracy using calibrated linear support vector classifier with class balancing, where we have mentioned the balance, right? And we introduced a conservative escalation, which is a risk-aware decision mechanism that automatically escalates nearly 14% of uncertain predictions to prevent production outages. The complete system now predicts category, assignment group, and the priority as well from a single ticket description. So now we have a model which is ready for the production usage, right? So that's all. I really thank you for watching this.